We tested on Thursday. So what would you like me to do? Riemann sums, area, between curves, under curves, whatever.
Can you do number 7 on problems from previous tests?
Yeah. Let me change that. Okay, I would take the derivative here. You know what I'm going to do is I record it. Okay. So just to see what that looks like. X squared plus 5 is over here. And this one,
We can't see your paper.
see, I will go back and find out why. I did desktop 1. How about now?
Yeah, we can see it.
Okay, very sensitive to everything here. Okay. So at 2/3, at 2 over root 3, what's that, 2 over root 3? That's a good thing. Yes, that's equal.
I actually think it was x squared.
Oh, those are the two curves. So x cubed, so x cubed minus x squared minus 4x minus 4. All right?
I think both of them were squares, so the first one is y equals x squared minus 4x plus 1.
Oh, I got a cube somewhere. Oh, okay. Then even shorter. So x squared minus 4x plus 1, and the other one is x squared plus 5?
Yeah.
Okay, so 4x equals 4, negative 4. Now 4x equals 4, that's right. Okay, negative 4x equals 4, so x equals negative 1. And y equals 6. X is negative 1. Yeah. So they meet at negative 1, 6. And since it's a square, it's a little bit easier. So x squared minus 4x plus 1. So if you take the derivative, set equals to 0, you get x equals 2. And when x is 2, y is down here somewhere, negative. And they meet at only one place. And they meet here. So this graph, I'm going to do another piece of paper, but this graph apparently is going to go up like that and into here. So you have at 5, you have that, and the two graphs only meet in one place, only meet at negative 1, 6. Let's say it's over here. And this graph is down here. And when x is 0 on that graph, y is 1. So this graph looks like they don't meet on the right, they only meet on the left. This graph has x equals 2, y is 4, y is -3. This graph, this has a vertex. This graph has a vertex over here. And it goes up, and when x is 0, y is 1. And it only meets here. So there's got to be something else. I read that again. Number 7. So x squared. They meet at -1, 6. Well, they don't meet twice, so okay, many of these, like we did that earlier on number 4, many of these were done on the board. So these graphs only meet at one. These graphs only meet in one place. Hold on a second, let me get mine. So if they only meet in one place, you have to have an interval. If they don't meet in two places, I have to give you an interval. So I probably did that on the board. So let me try it out here. X squared minus 4x plus 1. And then the other one is x squared plus 5. Yeah, x squared plus 5. If they don't meet, if they only meet in one place, get a graph on my calculator. Yep, and the other one, hold on. Eight. Hey, hold on, let me see if I changed it or what. Yeah, they only meet. Yeah, they don't. Oh yeah, in the calc, it looks like that. So I have to give you a region. I have to give you a boundary. Okay.
Okay, that was what I was confused about. Thanks.
Yeah, I have to give you a boundary. Now, on the ones that I gave you today for tomorrow, I checked them very carefully to make sure that that doesn't happen, because here, let me get the picture again. If I graph it on my calculator, I get basically the same thing up here somewhere. I get something like that. They meet only once. They have to meet twice to have a region. So when I did it in class, I probably said to x equals 1 or whatever. So you drew a line and you did this region. But okay, if you can't give me, okay, you can't find an area between two graphs if it's not a closed region. Okay, so that's no good. The 7's out without an explanation. Same thing with 4, sine and tangent. Sine and tangent, we did that the other day, they don't intersect. So I gave them a region. I just pulled them out. I didn't look for it's not a pretest. So are there any ones like that anymore? Probably not. But all the ones on the packet had 2 intersections, right? Yeah, I can't give you, it's like giving you 2 parallel lines. You can't find the area between them. Or 2 lines. If they only meet in one place, you can't find the area between them unless I give you an X, another region. Okay, so 7's out. What else?
Can you show 8?
Now 8, left Riemann sum. You're going to go, yeah, you have to be good at the Riemann sums. Actually, okay, let me do it here. On 8, and I'm looking at 8, and I don't know what that is. So that is, I don't know if that's minus, it's probably minus x plus 4, because I wouldn't write minus 1 plus 4. So maybe when I copied it from the test. So we have to decide on what we want x to be. So let's make it up. Okay, I could do this. Maybe it was 1x, but I wouldn't write a 1x. So I don't know what that was. See, it says minus 1 plus 4. I'm not going to write that. So let's do one of those. Let's do this from -1 to 3. Because that's what you need. That distance is 4, and we said 4. That means you could have 4 rectangles. So let's do x squared plus 4, because -1 plus 4 is 3. I don't see why that would be any good. So negative x squared plus 4. Even over here. And I'd have to give you again, I'd have to give you something like the x-axis. So let's do x squared plus 4 and the x-axis. That's this, from -1 to 3. It has to be bounded. So that wasn't bounded. Or I copied it wrong because I don't even know what that was. But it has to be bounded. So from here to 3, n equals 4. You should be able to do, let's see, we should be do all of them. So let's take, if you're going to do 4 rectangles, you divide this into 4, and you get each base is 1. So that's 1.
1.
Right. That's 1. That's 1. So it looks like this, 0, 1, 1, 2, 3, 4. So if you can divide to 4
Is that
places,
1 too many?
yeah, it's 1 too many. I don't know where they are. So you're dividing from -1 to 3. So that's 1. I did. He's not there. So what we want to do, we should do this, this, and this, and then you're covered. We should do all 3. So let's do all 3. But I have to give you a bound region like the x-axis. -1 to 3. So 0, 1, 2. You should have one more dot, then you have rectangles. So let's do them all. That way you're covered. S minus, so the base is 1. You can take, if you start from the left, it's obviously -1. That's this one. If you had to draw it, you'd have to draw this. But we're not drawing it because of the online. F of 0, F of 1, and F of 2. And there should be 4. And you just plug them in. So that's 5, that's 4, that's 5. I can't see it. And that's 2. So that's 8. 22. So it'll be 22. Now you should be able to do a plus. So a plus, the bases are the same. There's still 1s, but you start on the right, on the first rectangle. So it would look like this if you drew it. So it's f of 0, f of 1, f of 2, and f of 3. So f of 0 is 4, 5, 8, 13, 21, 30. Okay? And you should be able to do a middle. Now, depending on what the n is, okay? And the n is how many rectangles. If the n is, let's do 2. Let's do it twice. If the n is 2, that means you're going to have two rectangles. Okay? So let me do this again. If you have two rectangles, you're going to go from -1 to 1 and then to 3. So
Wait,
if
Mr. Shayo?
yes,
So when we do a midpoint problem, it's going to specify how many
Yes.
rectangles?
yes, because it makes a difference.
Okay.
So let's go n equal to 2. That means you can have two rectangles. So each base will be 2. 3 minus -1 over 2 is 2. That's your base. So it's your base times f of what?
0.
Yes, 0's in the middle. See, he's negative, he's the left, the right, the middle. F of 0 and f of
2.
Yep. And f of 0 is 4, f of 2 is 8, so it's 24. The same thing if I said n equals 4, okay? It's not proportional, whatever. And each case would be this, let me make it proportional. But if you're going to have, you have to know how many, yes, you're telling somebody, I want you to multiply the height times the width. Too bad we didn't do the applications because, see, if f of x is velocity and h of x is time, you're getting the distance traveled. But if you want, okay, let's say you want 4, 1, 2, 3, 4. So your first one is here. So you're going to take f of, guess what, for the middle. That's your first, that's the first base. So you have to take
Negative 1/2.
exactly. Okay. And then f of
1/2.
Yep. Whatever. And so on. 1/2, 1.5, 2.5. Okay? I can write it if you want. Yeah, the first one's there. Once you have your bases, you just go to the middle. If you were drawing it, you'd have to go here and draw the base. It looks like this. You'd have to go to the middle and draw your rectangle. So -1/2 for this one, 1/2 for this one, 1.5 for that one, and 2.5 for that one. So you should be able to do left, right, or middle, okay, if you know how many rectangles. If somebody may want to approximate it with 4 rectangles, or 2 rectangles, or 8 rectangles. The more you use, the closer you are to the actual value. That's why we use infinite sum. Oh, I want to show you something while we're here. It's not going to be on your test, but I gave you a new page. Riemann for AP or something. You have it? Riemann sums, AP style. You have that?
Yeah.
I think
Yes, Mr. Shayo, it's there.
Okay. It's not on your test because we're going so fast we don't have time. But it's going to be on your APs, so we're going to review this later. But let's see how this works. Remember, when you're integrating or doing sums, you're multiplying the height times the width. So they have meaning. Nobody cares about the area of a rectangle, the area under a curve. They care about what it means. Force times distance is work. Amps times volts is watts. Anything that's a product. So over here, velocity, feet per minute times minute gives you the feet traveled. So the difference here, so you should know how to do this, but it's not going to be on your test. I didn't want to pressure you on that. That's a use a right Riemann sum to approximate the distance traveled by the object. So you're going to add, you're going to take each 20, 15, 18. You're going to multiply the height times the width. You're going to get rectangles in here, okay? You're doing a right Riemann sum. So you're going to take, first, f of what? If you're doing a right Riemann sum, you can tell by the table. You don't even need the chart. F of what?
4.
Are you doing a right Riemann sum?
Let's see, you start at 6.
Yes. F, left, you'd start at 4. I have you do it over here. Right, so it's f of 6. Now, what's the base? What's the base? I'm making a rectangle. F
Would
of
it be
4,
2?
the base is 2. Plus f of, now you took these two and you took the right. Now you take these two. So f of 7 times
1.
that's right. So you can't do them all together, you understood the meaning. And then you take f of 10 times
30.
3. Okay. So you have f of 6 is 15 times 2 is 30. F of 7 is 18 times 1. And f of 10 is 20 times 3 is 60. Let me see what that looks like on paper, on a drawing here. So you have 4, 6, 7, 10, 12. So at 4, we went 20, 15, 18, 20 again, and 14. So your first base was 2, and your rectangle, you took the height of 4, at 4. I'm sorry, at 6. I'm getting my number. You took the height at 6. You took this height and you made a rectangle. You didn't take that height. That's your first rectangle. F of 6, which is 15, and that's 2, and that's your 30. Your second rectangle, you took the height at 7. The height at 7 was 18, and you made a rectangle. It looks like that. The next one, you took the height at 10, and you made a rectangle. And then you're doing right, you need one more. You need f of 12 times
2.
2. So it's 28. So you went f of 12 is 14. Let's say it's over here. The base is 2, the height is 14. See, these are your right-hand heights, and these are your bases. So for practice, not for today, because we have to review, but to practice, try number 2. The left Riemann sum, what's the average velocity? And here's your answer. So they want to make sure that you don't always go 2 times f1, f2, f3, f4. You have to realize that they are rectangles, and each one has a different base. Okay, so if you could take a region and do left, right, and middle, as long as you know what end they want you to use, you're okay. So the middle is no different. You still have to know, even if you're doing left hand, you want to know how many you want. So on all the Riemann sums, they have to give you how many rectangles you want to approximate it by. How about the packet? Any on the packet? Areas between, above, in the middle, H.
Could you do 2 from HC?
HC. Now when you do the sine squared, HC is sine squared. Yes, no?
Yeah.
Okay, so the sine squared, the reason in pre-cal that we did sine of half an angle, we did this. Remember that? We used to do that and ask for the sine of 22.5 or something dumb like that. The reason we did this is not to get the sine of half an angle, because we can get it on a calculator, nobody wants it. The reason we did this is because when we square this, you get that. So the angle on the left is obviously half the angle on the right, because it's a half angle. So the angle on the right is twice the angle on the left. So if I change this to x, I change this to 2x. So now what happens, anything you want to do with sine squared, you could do with that. So if you want to integrate sine squared, you can just take 1/2 integral of that. So it's 1 for the 1 minus integral of cosine is sine. You need 2, you need a half, so you take out another half. So it's 1/4, because you already had a half out, sine 2x. And you can plug in whatever. Same thing with cosine. So if you want cosine squared, you're going to get 1 plus cosine. They come from the half angle.
Wait, Mr. Child, can you scroll up a little bit so I can see your work?
Yeah, when we derive sine of half an angle, we got that. Which means that if you square it, you don't get a square root anymore. So the angle on the right is always twice the angle on the left. So if he's an x, he's a 2x. So now we have an easy way to work with sine squared of x without worrying about a square. Okay?
Okay, thank you.
You're welcome. There's another way to do sine squared, but many times you're in the middle of a problem and you don't want to have that, so you change it to that.
Wait, one thing I'm confused to is you changed the half
Sine
angle
squared,
into an
yeah, I changed sine squared. Well, okay. I wanted to get another name for sine squared x. So I realized that if you take a half angle, you get a square root. If you square it, you just get that. Then I said, hey, if he's x, he's 2x.
right. Okay, thank you.
So now, if you have to do something with sine squared, you could do it with a non-square. Okay?
Yeah, okay, thank you.
You may have something like, let's see, on number 1, see, the problem I have is that it's a multiple choice thing. So problem, and I also have the problem that some people integrate already on the calculator. The problem on here, I would say it reduces to, oh, that's not the best one to pick, but I could use 1 plus x. It reduces to u to the 1/2 u minus 1 du. Let me make it realistic. From 0 to 3. Okay. What did I do to get this? What method?
Substitution.
Substitution, very nice. And what will go down here? Anybody know?
0.
No, now we're doing u's. Remember we did this. The x's start at 0. So we did u is 1 plus x So x is u minus 1. So I changed it, right?
Yeah.
We did that. But these are u's, they're not x's. So what goes here?
The 1.
Ooh, and what goes here?
4.
4.
Yes, because if x is 0, u is 1. If x is 3, u is... So that would be a good multiple choice. I want to see if they remember how to change to use ln's and all that. So I have 1 on integration. I don't know exactly what you guys have, but probably about 3 on area and maybe 2 or 3 on Riemann. Okay, what else? I don't think every single student did all the problems. I'm getting 2 people. Maybe you did, I don't know. You have over 100 problems, 59. I don't know. You have about 70 problems on the packet. So somebody was asking about the horizontal. We talked about the horizontal. I'd like you to be able to do a problem both ways. 9. So you know how to break it down into rectangles, to left, right, middle, and can you integrate also? Let's make a line here. Let me make this up here. So we're going to x squared, 3, 4, 9 isn't a good number, 6. Let's see what that does. Negative x squared minus x. If I want to get 6x minus 9, x squared plus 6x plus 9. Or if I want to get, see, I make up a polynomial and then I make a line, okay? If I do y equals x, okay, you get x squared plus x minus 9. They're not going to factor nicely, so you're not going to be able to get, later on, we'll do it on a calculator and you'll be able to find the exact place where y equals x. It's that. I picked a bad number because 9 is just 3's and 3's. 9 and 1, how could I do 8? Do 8. So if I had y equals 8x, okay. That is this and this. So you set them equal. So you get x squared plus 8x minus 9 equals 0, and you can factor it. So they would meet at 1, and they would meet at negative 9. That's how I make the problem up. Okay. So we'll do it. So you should be able to do this if you have expertise.
Mr. Shia, how many problems did you say, or of each?
Oh, I was roughing it. I said, you should have probably 3, 4, this is B. I can probably tell you if I can find it. You have about 8 problems roughly. So you have 3, 4, and 4, 4 area, 4, let me see what you have, 4 Riemann, it's about split. Exact area, that's 2. You have an integral, a Riemann. Let's see, you have 2 areas, an integral, a Riemann, another, maybe I can show you what I'm doing here. Another sort of an area, doesn't mean I need you to find the area. And then you have area, and something else that nobody asked about is on there, and area, so mostly area. So on this problem, let me show you what I did. I can't write them out, like, and have you hand them in. So on this problem specifically that I just did, look, I said, in doing the area with vertical strips, the limits would go from, and you'd have choices. With horizontal strips, I may say from where to where. That way I can write it out with this Google form thing. So, if the area between these two functions, the graphs of these two functions, question would be, your vertical, if you're doing vertical strips or vertical rectangles, the limits would go from where to where, and if you're doing horizontal, from where to where. So should we do it? That's,
Yeah, can we?
you definitely have something like that. So the first step, so I'm checking out, do you know how to, you have to set them equal. So when you set them equal, you got x squared plus 8x minus 9. So you get x plus 9, x minus 1. So they meet at 1. If x is 1, y is 8. And they meet at negative 9. If x is negative 9, y is negative 72. You don't have to, you can plug them in either one. And so if you're doing vertical strips, that's this way. Your limits would be from where to where?
Negative 9 to 1.
Yes. So all you need is 1. I didn't give you this one, but I could. If your horizontal strips, starting from the bottom, how many horizontals do you need?
You would need 2.
Very nice. Yeah. And the first one, the lower one, will go from where to where?
It would go to negative 72 to 8.
Very nice. I don't know how many of you know that, but yes, that's what we're doing up to here. And then the other one would go and 8 to, that should be easy,
9.
8 to 9. The limits, we're not talking about the function. In other words, it's going to look like this. Okay. Now, do you know what this function is?
It would be the negative x squared plus 9 plus,
No.
sorry,
that's
negative.
No. This guy, that's the y. This is x1 minus x2. So if y is negative x squared plus 9, x squared is 9 minus y. So,
Yeah.
the x on the right is
9 minus square root of 9 minus 1.
Yeah. And the x on the left is negative square root of 9 minus y. So what would go in here if you simplified? What would this be?
2 square root of 9 minus y.
Two of them. Very nice. Because they're the same on both sides.
For like the x2, why would it be negative? Is that because it's in the negative side?
Yes, because, yeah, you're dividing it up into two parts. Here x is a positive, here x is a negative.
Yeah, okay.
It's
Because it's decreasing on that side.
yeah, even if
technically.
it's over here, you separate it and you get negative 3 plus the square root of 5, negative 3 minus the square root of 5. From the vertex to the right is a positive, to the left is adding a negative. It's always at the vertex. Very nice. Yeah.
So in the case that you showed us at the bottom of that page,
Yeah. Hold on. Who am I talking to?
Vishwak.
Very good. Okay, go on.
If it's decreasing, then it's going to be positive, basically,
It-
after the vertex.
Yeah, the one to the right of the vertex is a positive. The one to the
Okay.
left is always a negative. So if you
All
have
right.
to choose between these and these, A and B, who's on the left?
It would be B, would
Yeah.
be on the left.
He's left and he's right. And when you
All right.
subtract them, you get two of those. You get 2
Yeah.
root 7 minus x. Cool. Yeah, very nice.
All
Total
right,
down.
thank you.
Very good. Very nice. Very impressed. And I know it's not my whole class, but still, it's good. Some of you are doing very well. Okay. Okay. Yeah, the weekend was crazy. I had 7 tests to write in Google Form. That means even if you write it and you get an answer, you have to put it into that Google thing, and the Google thing doesn't always accept everything. And you have to write, anyway, I don't want that. What is that? Is that Teresa? What's that?
Call from Deal F. Call from Deal F. Call from Deal F.
Okay. What else from the packet? What else? So did you understood that the one we did for the AP?
Yeah, it made sense.
The only difference is that the bases might differ. Okay. So that's what that was about. That's not on your test. But once you realize that you're the only thing you're doing is taking areas of rectangles. If you don't have any rectangles there are, you look at each base, multiply by the height. If it's left, you take the left height, right, you take the right, middle, you take the middle height. That's all you're doing. It's not complicated. It doesn't help the calculus, except it shows us what we're doing when we're integrating. Any questions? So I was telling you, you have, oh, I didn't count them. Did I count them? I don't know. Yeah, oh, I know. Number 1 is what's your name? That's not a question. So you have, oh, that was the wrong period, but they're pretty much the same. Hold on. Oh, I thought it was, no, that wasn't yours. Do I have A somewhere? Hold on. A, B, C, engineering, Stanford. I have engineering, Stanford, 3 APs, a pre-cal and a BC. So no wonder I don't get it all right. CA, here's A. Okay, let's see. You have, oh, that was a quiz. That's no good. I don't know where A is. Hold on. I was going to look for yours to see if it did it. That. I don't know where A is. No idea where it is. But I can look it up. That was B. It's almost the same. Blank with B. Oh, I'm gonna look up your quiz, your test, see what I can find. Oh, I think it's this one. Yeah, no, that's vectors. Inverses, that's B, pre-cal. I lost your test. Okay, I don't have it in here. Okay, let's see. I'll tell you what you have. So, okay. Go over here, close that out. Period 3. Period 3. Where's edit? Maybe here. No, that's not right. Here it is. Potassium. Edit. Now you get 10% bonus. Hand it in within a minute. Oh, I'm going to do something else, but I have to do it. I just make a lot of work for myself. We didn't get all the papers handed in, the syllabus. Remember that deal?
Yeah.
So what I'm going to do.
Wait, you told us that each individual person would get 10% that turned it in.
I already told you?
You did.
Oh, okay. Yeah, BC I did 5. Okay. Okay, so let me see where we are here. You have area, Riemann, pretty much an area problem. Area, Riemann, oops. You know, like I give you an infinite sum or something. That's it. Sure.
Will there be any like midpoint value sum or like average value sum?
You should know. 5. So yours is short. Well, short's not so good, but it's okay. Yeah, you have a short. It's only 7 problems, so you have to be very, maybe I didn't count right. 1, 2, 3, 4, 5, 6. 1, 2, 3. I don't know if this is. Anyway, you're gonna have 6 or 7 problems, but it's your test is. I believe it's 300 points. No, it's 400 points. So the problem with that, obviously, is that each problem has a lot of weight, like 40 or 50 points or more. Let's see what I have here so far. So you have to be very, very, very careful. You'll have some, I think you'll be okay on your time. Well, we'll see how it goes. Okay. So mostly areas, some Riemann, infinite sums. You know how to go from done a lot of those. Draw in your packet to go from an infinite. Oh, I bet it's here. Is that it? No, that's back there. You know how to go. But you know how to write it an integral as an infinite sum expanding, right? So if you have to write something simple like 2x minus 1 from 3 to 8. You know how to write that as an infinite sum? What do I write for each base?
8 minus 3 over n.
Yeah, you're going from 3 to 8, and you divide into n parts, and you let n go to infinity. So each base is infinitely small. It's almost 0. So then the issue is, you have to have a rectangle. So when you move out and up, you're going to get your first rectangle here. That's why we picked the one on the right. So your first x is what? Starting at 3, x is x.
Multiply it by 2 and subtract 1.
That's it. The next x is 2 times 3 plus 10 over n. Okay? So once you know what you're doing, I'm very contented with that. Because most students in most schools have no idea what they're doing when they're doing a sum.
What would be like the final term? It would be like 2 times 3 plus 5n over n.
Well, okay, you take one of these, then you took 2 of these, and then you took what? How many rectangles are there? See, when you do 3 rectangles, goes 1 to 3, you took f of 1, f of 2, f of 3, okay? You took 1 base, 2 base, 3 base. Here, you're taking n bases, but they're letting n go to infinity. So you take one of these, 2 of these, and your last one is n of these. So you have 3 plus 5 over n, 3 plus 2 of those, and finally you get 3 plus n of these, and this, how much is that? 3 plus n, 5 over n.
8.
And that should end up at your top limit. Because that you started at 3 plus nothing, and you ended up 3 plus 5. So that's what's happening. If you don't end up at the end, then you have something wrong with your sum. Okay? It just looks very weird. And those people that were trying to get areas that way, it was very difficult because they didn't know how many rectangles to use. So once again, what Newton did, he said that you want some area function from here to here. So he says, if you take the area to x plus h and you subtract the area to x, you get the area of this region that you want. But that can be written as this base times some height that replaces these. Which height did we use that replaces all of them?
Dx or dy.
No, you're not thinking. What height do we use that replaces all of these heights. This is f of x.
The average.
The average height. We didn't take the low height, we didn't take the high, we took the average height. So then he took this expression, he divided by h, and he was end up with this. And he says, oh, I've been here before. So he took the limit as h goes to 0, and on the right side, he got a prime. And on the left, what did he get when he took the average value from x to h as h goes to nothing? Remember, anybody remember what this was? What's the limit of the average value of f as h goes to 0? You're going from here to here, but you're not really going. So what did he get? What's the average value of f of x if you don't go anywhere?
1 over b minus a.
No. What's the average height? These are heights. F of x1, f of x2, f of x3, these are heights. What's the height from here to almost nowhere?
Is it just f of x?
It's f of x. That's the beauty of this. So he said, oh, the function you want the area of is this, a of x plus h minus a of x over h. Oh, the derivative of your area is your function. So if you want to find the area under x cubed, you need a guy whose derivative is x cubed, okay? You need that. You want to find the guy whose derivative is, you want the area. The derivative of your area is your function. That's how you're going to get your area. If the derivative of the area gives you a function, your area must be the anti-derivative of f. So you want the area under x squared, he said, find this. Find the antiderivative, because the derivative of the area gives the function you want. And that's his proof. That's how we got into antiderivatives. Says, I don't know what the area is, but I know that the derivative of your area is the guy you want. So if you want the area under 2x, okay, the area is the guy whose derivative is 2x. It's x squared. Anyway, so that was the review. We'll do that again sometime. It's not on your test. Okay. So, what else can we do for you? I think you guys are pretty ready. I might modify this a little bit, but you're not going to have, you have probably about 8 or 9 problems at the most. 7, 8, 9. And that puts you at almost 50 points a problem. So you have to be very careful with each problem. Okay? And I can tell, if you know the packet, then you know your test. It's that basic. I mean, it comes from there. Area between curves, area under curves. Okay? Anything else? Last minute.
So Mr. Shire, just making sure. So when you're looking at horizontal problems, you want it like you have to look. Sometimes you have to use 2 integrals, or right?
Yeah.
Yeah, because they separate out like
Right.
at a certain point.
Yeah, exactly. And it doesn't matter if it's horizontal or vertical, but I would say from 0 to 6, you go, oops. Oh, you can't see. Hold on. Yeah. So if you want the area between this curve and this line, you're going to have to sweep this and then sweep this. That's what I check. That's why even if I give you x squared minus 1, I probably go from 0 to 3. So you have to sweep that and sweep that. And you have to hand your work in, so it's very important that your work matches your answer. If it doesn't, I think it's like a 200-point penalty or something. So just make sure your work agrees with what you did, okay? You didn't pull it out of the hat somewhere. Okay. Yeah. Okay, then we have to learn, I don't know what's next. I think we have to learn how to integrate, because there's a lot of stuff we cannot integrate. Like x e to the x or anything like that. Or the square root of 1 minus x squared without an x. These are all very important. So I'm going to show you how to integrate anything. And I don't know how I'm going to write my test, but one thing after the next. Anyway, so have a good day, get some rest, and I'll see you guys on Thursday with a nice test.